All right, so today we're here with the class on the vertical mill. So again, we're in the lab. I'm going to talk about things on the presentation, and I'm going to talk about things and actually run the equipment so you guys can see exactly what I mean. If you have questions, you can always come and ask. And it's going to kind of complement what you guys have seen in the lab. All right. So we have two kinds of vertical mill. One, that's a knee one. That's the one that we have, right? See, I can flip it. You're gonna see it. So like this is the one that we have, and this is the horizontal one, which is a little different. So that's the vertical one. See, it holds our cutter in the vertical position, and you're gonna have the file with all the names of everything attached to your module. So you can always go back and refer to it. But we're gonna talk about these things, and I'm gonna show it like right on the equipment, right? Right, the head. So actually, let's go back here. I don't know if I can. Let's see. Let me put the camera bigger. All right, that's me. Right, so let's see, Logitech Brio. Right, so this is our machine. Right, this is the DRO, the digital readout. Okay. Right, digital readout is on. So the digital readout would actually have the information on the X, Y, and Z. So when I move one of the axes here, so I'm moving here with my hand, and you can see that the x-axis, right? So this is the x-axis, the sideways move of our bed here. So this is Y, the back and forth move of the bed. You can see there. And the Z is actually this big lever, right? So for every axis, we're also going to have something to make it not move. For example, we have these two dots here to actually hold, so I can't move my x-axis, right? Why do we use that? We use it so when we're cutting something, so we have our cutter here. So right now I have to install the holder and then the cutter, that's the end mill. And then we put our piece here. When I'm cutting, let's say I'm side milling a block, right? So I have my block here being held by the vise. I have my cutter here, so I'm side milling a block. So when my idea is I just want to cut in the y-axis, right? So I position in the x where I want it to be, and then I'm gonna move in y so I can take the cut, right? If I don't lock the other axis, what's gonna happen is vibration might actually change my position on x. So I would want to actually lock the axis that I'm not using, right? So these two are the locks on the x-axis. I have two locks here that will lock the y-axis, right? And let's see. I have the locks back here. That's the lock with Z axis. Right? So for the axis that I'm not using, I wanted to have it locked. Right? So let's see. From this, we already talked about the locks, right? Cable locks. On the bed, we have a vise. So the vise has to be square with your bed and the axis. So our cut like it comes out square, right? We can actually talk about this further later. So when we put the vise on it, we actually try to make sure that it's actually square. So when I move in this axis, my vise is not sideways. So it takes a square cut. All right. So we have the motor up here. We have the motor up there. This is the speed control. We have to turn the motor on. Oops, sorry. Right, we have the motor up there. We have the speed control. We have to run the switch to run forward or to run reverse, right? Why forward or reverse? On this side, we have gears. So right now it's in high. There's high, neutral, and low. So we're in high, we can go to neutral, or we can go to the far end low. Right now it's not going on low because my gears are actually butting together. See, so like I am actually moving the tool a little bit, and now it goes on low. The thing is, when I switch from low to high or high to low, the orientation of my cutter, of my quill, is actually going to change. So in high, we want to cut forward. When we are in high, where we want to cut forward. In low, my tool here is going to spin in the opposite direction. So then we want to keep cutting. So like we're going to cut it in reverse. You're going to see that in the class, but like that's just something. We never change this levers when the machine is on. And when the machine is on, we can change the speed, right? The speed up here. And see, there's high, right now it's 2,200 RPMs. Low would be, if we are in low, then you read on this side. If you are in high, then you read on this side. So but the speed, we don't change the speed when the machine is not on, right here. So you want to set up the gear, turn on the machine, and then now we can actually change the speed. Gear, turn on, speed. Want to switch gears? You have to turn off, wait for it to stop. Then you can switch gears. You can turn on, change speed, right? All right. All right, so we have, we already talked about this. That's what moves in Z, moves in Y, moves in X. We have the quill, spindle. All right. Let's see, there's a table. Our vise goes on top of the table. The digital readout reads X, Y, and Z. We're talking about the variable controls. All right, so one thing that we can do here in this machine is I can actually lower the position of my quill, right? And that's my spindle. So I can lower the position of my quill. The thing is, we can work with it all the way to the top. That means if we're cutting something, it can bounce back and forth, or we can lock its position. See, there's a lock for the quill there. So right now I can't go down. I can force it and actually like damage it, but so this is actually the lock for the quill. See, so some people say that like it's good if you not work all the way to the top. For example, if for any reason you get stuck, you might want to actually raise your cutter, and that would give you like a some clearance to figure something out or to get the problem solved. However, if you're working all the way on top, you can go any further up because we're already at max, right? So sometimes we just like pull it down and then lock it. And then now this thing is not going to go neither up or down because it's just locked. All right. Or if you have it all the way up, have it all the way up, I would say lock it in. So it's not going to bounce when you cut, right? So that if like the other reason for actually lowering the quill is if we have a chuck installed here, and a drill bit, we can use this as the drill press. Okay. That's a few things about. Let's see what else. Column knee. All right, so this is generally everything that we need to know about it. All right, we already talked about this. So we have the quill feed handle, the quill position lock. Let's see. Quill, which is this. If the spindle runs inside the quill. Spindle brake. So the spindle is actually what rotates. The spindle is actually what rotates, and it's holding the tool, and that's how it cuts, right? If this guy is rotating and we stop the machine, we might want to push on the brake so it stops fast. So this is the brakes for the spindle. Another use for the brakes is actually to get something tight, some tool tight. We might want to actually push on the brakes and then get it tight or get it released. So that's another use for the brakes here. Reverse and switch, variable speed dial, which is this. All right. So the important things about this is, let's see. Let's go here. Huh? So a few important things. We have to have the right speed to cut, right? So let's say we already know that. Now we have to choose the tool that we're going to use to cut. So let's say we can have an end mill. So an end mill with the end mill, I can cut on its side. I can cut on its side, or I can face it. Let's see if we can see. If I just travel like this on top, then I can face the top, right? But it doesn't have any cutting edge for me to plunge. So we shouldn't be plunging with the end mill. You can plunge a little bit, but like we're trying not to. See. What's the other option? The other option with this machine is actually to have so with the end mill, the other option is to have a drill bit. The drill bit doesn't have any cutting edge on the sides. The only way that it cuts is actually on the cutting edge here in the front. So this one we can actually side mill or face. This one we can actually drill. So that means plunge. All right. And I have one more detail about the drill bit, right? So if you decide to get a drill bit that's big enough, like this one, did you guys notice that the shape of this is like that? So that's our drill bit right there. So this is a cutting edge right there. This is a cutting edge right there. However, this piece here right on the tip, that's not a cutting edge. So what does that mean? That means if I want to use this drill bit, I wouldn't be able to start the hole with this drill bit. We would have to use a smaller one that doesn't have a chisel tip like that one. All right, so let's see this one. See, it also has that little flat top here. All right. But if we use a smaller one, if you get a small enough one, then you see you don't have that chisel tip anymore. So you can use it to actually drill the first hole or the pilot hole, right? All right. One more thing is, it's not that you have to start the hole with it, but for example, imagine that this is our surface. You have the drill bit here, and you want to make the hole all the way up to there. The pilot hole, if you just drill the pilot hole up here, your bigger drill bit is going to be able to come in, but once it faces this surface here, then it's going to stop, right? Because it can't drill. One more thing, the pilot hole, so like the pilot hole has to go all the way down to whatever is the max depth that are gonna use this drill bit for, the bigger one. Also, the pilot hole has to be wider than the chisel tip here, because this area doesn't cut at all. All right. Good stuff. The drill bit, plunge, drill, the end mill, side and face. Right? We also have here another tool that's some people call a facing tool. or a flywheel. So we also have the facing tool here. All right. So for each of these tools, what I'm going to need to do, so this is our machine, right? We have the motor up here with the speed selector. You have the motor up there. And then you have here, and you have your, so this is the tool. And then down here, we have the vise holding whatever. So we have to adjust our speed. We have to use a tool for whatever we want to use. And we have to secure the tool. So there's something here in between the tool, between the tool and the spindle. There's a tool holder. So the tool holder for the drill bit will be the chuck. The tool holder for the flywheel is actually the flywheel itself. See, you have the threads there to actually hold it from the top. And the tool holder for the tool holder for the end mill is the collet, right? So for us to actually be able to hold this, we will have to let's see. Up here, I have a drawbar. See? So a drawbar is just a pretty long bar with a screw on the end. See, some threads on the end. And those threads are actually going to thread into your tool holder. See, just like that. So in this case, the collet, or it threads into your chuck. And for the flywheel or the facing tool, there's no holder for it. The holder, it's the tool itself, right? So when I thread it there. So what's going to happen is so this is what's happening here. So let's look at this, but on the inside. So I said that we have that bar that goes all the way through the head. And then yeah, I have some threads here on this side. And then this is actually, let me change this. So this is the inside of my spindle. So this is the inside of my spindle. What's my spindle? My spindle is the rotating thing. So this is my spindle. However, we are actually taking a cut like this so we can see what's in there, right? So when I insert my tool into the spindle, that means, so this is my tool. It's like this. And at some point, you have these sides that are not parallel. See? You have the sides that are not parallel. And then you have whatever tool here. Let's say that you have the flywheel. Right? So we have treads on this end. So when we tread the drawbar in here, you are actually pulling this guy up. When you get so tight, the inside of the quill is actually going to match with this dented sides here. And it's going to have a perfect binding, right? So that's how we're going to hold our tool holder or our flywheel into the quill. Good. All right, let's see how it's done. Again, I can put this in here. And then now I'm going to actually screw this from the top. He wants to come with me. See? I actually screw this from the top while I hold the tool with my hand from the bottom. That's what I'm going to do. I'm going to hold here and screw here from the top. All right. Once it's tight enough, it's actually hand tight. Then now it's time that I'm going to go to this wrench that's on the side. I can put on the hex head of the drawbar up there. I would hold the brake, and now I can get it out. Good. So that's how we're gonna hold. When we're gonna release it, holding the brakes, put the wrench on the hex key up there, and we can screw off. And then now I can just hold it here from the bottom and actually unscrew with my hand on top. A thing, don't leave your key up there. Your wrench, don't leave your wrench on the drawbar. Why? If you leave your wrench on the drawbar, you're gonna forget about it. You're gonna turn on. Your wrench is gonna hit your motor housing right there, and it already happened. So don't do that. All right. So we use the wrench, and then the wrench has a place for it to go. Right. Right there. The wrench goes right there, and we're good. Another thing. This is not the wrench that goes up there. Oh, but it fits. It's fine. Not the wrench that goes up there. This is for the vise, right? So this is just to get the vise tight. When you're not using it, guess what? It goes on the holder right there, right? Because sometimes like it's on the way, or if you leave it here, you want to move you actually want to move your X, and then as or you want to move your Y, and the key for the vise is here. So then you actually end up like a moving, like opening the vise or closing the vise, you know. So that's kind of a, if you're not, after you secure your stock, you can already put your key for the vise there. You're not going to use it anymore until you need to move it again, right? If you're organized, it makes our life easier. So in the lab, you have a certain amount of time to actually complete the work, because I wanted to come here to prepare. You should know how all these things work. And I'm gonna get, the first step is to secure this. The second step is to do this, like based on those steps. Then there's no more actually messing up with the device. Or take the key, put it down there. Oh, there's moving device. Get the key, open it up, close, put it back there. Good. All right. Let's see what else. So now we're talking about the whatever cutting tool you're using and holding the cutting tool, right? So for this to work well, we have to have the right speed, we have to have the right cutter, we have to secure the cutter correctly, right? So we're on that step. So there's one thing that I want to point out to you about securing the cutter. Let me change my camera here. So you are going to have, so this is a collet. See how the collet has like a pretty thick sides and it's all over in these little slits. And the chuck has actually little sides with big splits. This is so when you're using the drill bit with the chuck, you're only going to use it. You're only going to use it to plunge. You're not going to be moving sideways. And when you're using the end mill, you're going to be using a collet. And you're not going to be plunging. You're just going to cut to the sideways or going to face. Right? So how the tool holder is built depends on the movement that you're going to do with your cutter. So I shouldn't use a collet with a drill bit or an end mill with a chuck. Good? All right. One extra thing. When you choose the collet that's going to go with your end mill, you have to choose one that are going to be pretty flush in there. See? Why is that? Because when I get this tight, so I said that we're going to put this inside of your wheel there. Our drawbar is going to go in there, is going to pull it up. This is going to sit inside of the spindle. And the more you actually get it tight, it's actually going to close these slits and it's going to actually hug your end mill right there. However, if you grab an end mill with a big hole, even if you close the slits all the way, it's actually not going to be tight enough so it's going to hold your end mill. So you have to choose one that's actually pretty tight, right? So we have a set. We have a set of collets. See those right there? So usually what I do is actually I grab my end mill and then I go and I try the different ones until I see, oh, this is pretty tight, right? And that's the one that I go with it. See? Good now. So this, it goes in there, but see that the gap is just too big. Even if I get this tight all the way, I'm not going to be able to hold this end mill. I would have to choose something that's actually pretty flush, see? There's no holes here on the side. Right. So end mill goes with the collet. End mills with the collet drill bits with the chuck. And a flywheel by itself. It already has the threaded back that we're going to use, right? All right, so let's go back into our story here. So we can start doing the job, right? So we need the right speed, where the two to cut. If you use an end mill, you're going to need a collet. And then you're going to need, yeah, the end mill with the collet. And actually, we need the correct collet. If you're going to use the drill bit, or we're going to drill, take a plunge, we are going to need what? If you're going to face, we can just start using the facing tool, and that's all that you need. So we need tool to cut. And actually, we need to hold tool. That's important. All right. Now we need the stock. What's the work? What we're going to cut? What are we going to cut? So now we need to position. So we're going to hold in our vise, and our vise is already square. So we need to hold. So position is about holding and also about holding correctly. So you need your vise, and the vise is square. So the vise is actually going to hold my piece here. However, when I'm cutting, let's say I'm facing, it's not easy to cut metal. There's actually one metal that's harder rubbing on the other one to actually extract the material. Cutting surface, it's kind of difficult. So it's kind of like I'm going to push it down and push it to the sides, right, as it does it. So we want to use what we call parallel plates without positioning it. On our toolbox there, we have this parallel set. They all look the same from the top, but the difference is actually how deep they go. Why is that? Why do we use this? So this is what we're going to use it for. This is actually very important. That there's a chance that you use some sort of like a drill press or vertical mill before, and you didn't know this, so you're not doing correct. So what we want is, I said that as we cut, I'm going to push things to the side and down, right? But I don't want it to go down. For it not to go down, I can use the parallel plates. So let's see. I'm going to put the parallel plates on the sides. And then I can actually close it. Once I'm holding, I'm going to push it down. So now, see how we have these two things on the sides here? My piece is actually sitting on top of it. So if I try to push it down, this thing is going to prevent it from actually going down, right? So that's the parallel plates for. Which parallel plate do I use? I said that the difference between them is how deep they are, right? So you want to choose one that you're going to have enough contact between the sides of the vise and the piece. See, that's only this top part here. There's only this top part. Good. And you don't want to leave so little up here that there's a chance that I'm gonna go so low with my cutter, and I'm gonna hit my vise as I finish my cut, see? So I want to have enough actually going above, so there's no chance for me to actually, so choosing the correct parallel plates is actually necessary. All right. So my camera, stock, we're gonna hold with the vise. Now, to position inside of the vise, I need the parallel plates. Right? So this is needed. All right. This block that I'm using is the one that you guys already worked on. So actually it's already squared, see? Not some of the sides, but the top and the bottom are squared. See? So there are two sides that are squared too. See? This side. So yeah, this side here, this side, and that side. So if the sides are already squared and the bottom is squared, and I already deburred it, I can actually sit it on my vise. I can sit it on my vise, and it's going to sit correctly on the vise. All right. However, it's not square. Sorry. So now I'm got a piece that's not square. It's just a piece of aluminum which they'll just cut off like with the horizontal bend saw. Even though this is a 2x2 aluminum square stock, see, the sides are not perfect like square. So, and the bottom is actually not also square to the sides either. So there's a chance that I'm going to put it here and I'm going to secure it. But what's happening is this. Let's try to kind of like so this is what's happening. The sides of this block, they're not square. Square means perfectly straight. And so this is not rough. And sides are parallel. I can't say that because it's just like rough stock, right? So there's a chance that my block is like this. And I want to secure it on the vise, right? So what happens is, if I get this guy tight to hold it, this is how much I'm gonna hold. So I'm holding right there and right there. I'm holding right there and right there. So this is what we have. So if we are just holding in this few spots, when I try to cut it, it's actually not gonna do well because your contact surface here is not enough. So one way of fixing this up is if I add some material here on this gap, that's actually soft. If I get it tight, it's actually going to fill in all this thing here, all this gap. So now my contact surface is actually all of it. It's fine that the other side it only has a few, but like see this side has all of it. But that's what we want. So what we do is we use some material that's pretty soft that we put between the vise and our block. And then when we get it tight, he's going to squeeze it and is actually going to fill in that gap. Now we're holding it correctly. All right. So let's recap. We have the vise. These are the jaws. We have our block. They want to cut. It's not square yet. We need the parallel plates on the bottom. Right? So if I push down, it's not going to go down. Then I need that piece of soft material running here on the side. So when I close this, it's going to squeeze it and actually hold it from there. All right. Also, what I want to do is actually, when I'm actually closing this, there's a chance that there's some burr here right on this edge here. It's not going to allow it to sit correctly. So we're going to use a deburring tool to actually deburr the bottom of my piece, right? So how do I do this? We never go like this. Forward. I put my thumb here. I'm gonna bring it back. See? It's actually gonna cut the edges there.